So that's Newton's first law. Let's have a think about his second law. What does Newton say about that? Well, he says that the change of motion is proportional to the motive force impressed, and it is made in the direction of the right line in which that force is impressed. Which basically means that if you kick a ball in one direction, it's going to go that way. This is fairly easy. So we apply a force, and an object will accelerate in the direction that we've applied the force. So that's what he means by the right line. When he's talking about the change in motion, well, that's more like what we think of as momentum. However, Newton's second law, you will have met it as force is mass times acceleration. And I can guarantee you've probably done an experiment at GCSE using that equation. Now, but I said that Newton talks about momentum, so let's have a look at how we can get momentum into this equation. Remember that acceleration is the change in speed divided by time. So if we put that equation into F equals ma, then we get F is mv minus u divided by t. Okay, rearrange it a little bit and hey, there we have mv minus mu. V and u are the final and initial velocities, so we've got force is final momentum minus initial momentum divided by t. So force is a change in momentum divided by time. Now, in physics, for some reason, we use a different symbol for momentum, but let's think about the units first. So the units of force, newtons, momentum, kilograms meters per second, time in seconds. So those are the units that you're used to. Now, as I said, in physics, we use P for momentum. I guess it was because m was already taken in F equals ma. So we can rewrite this equation as force is the momentum afterwards minus the momentum before divided by time. So we can look at this in two different ways. And when you have physics questions, there'll be two types of question that you're asked. One is where there's a change in velocity. Car crashes, snooker balls, that kind of thing. Where two objects collide and there's a change in the velocity but not in the mass. Or there's a change in mass, which is rockets and explosions. And in those questions, you've got to be very careful about what your mass is. So in a little while, when we come to look at these types of questions, bear in mind, is the mass changing or is the velocity changing?